Good afternoon, everyone. Welcome you all to the online lecture series hosted by Additional Skill Acquisition Program. So this is Sanakha. I'll be your moderator for today's session. So before we get started with the session, a few points to keep in mind. So it will be a 1 hour session, and we'll be having time for Q&A at the end of the session. You can post your doubts in the Q&A chat box that's available at the bottom of your screen. You could see the 3-dot icon. Once you click on it, you can find the Q&A chat box there. And while posting your queries, please make sure that you're marking panelists while sending them. So today's session is on 6th semester subject, computer programming and computational technique. So we'll be discussing on a few topics that comes under module 6. Today's topic of discussion is Gauss elimination method and curve fitting. And for that, I'm indeed privileged to welcome Dr. A. Praveen to begin with today's session. So, just a brief introduction of this of the speaker for today's session. So Dr. Praveen is currently the professor at Department of Civil Engineering, Rajiv Gandhi Institute of Technology, Kottayam. So Dr. Praveen has started his teaching career in 2000, and he has got an extensive academic experience thereafter. Dr. Praveen was awarded his PhD by National Institute of Technology, Calicut, and his master's and bachelor's degrees from University of Kerala and Calicut, respectively. So it's indeed our privilege to have Praveen sir joining us today. Welcome to the session, sir. Over to you.
Thank you so much for your words. So we move to the discussion of module 6. The topics that we discussed today, even though the spans of their academic content is completely tailored. So hence the method of Gauss elimination. Okay. Audio, is it okay now?
Yeah, it's better now. It's better now.
Yeah. So in the Gauss elimination, one of the important tools for the solution of linear equations. Linear equations, we all have studied linear equations in our basic mathematical classes, where to get the solution of unknowns, perhaps we then called as variables, can be x, y, or some unknowns which get embedded in your equation. Either we use a process called back substitution, or we may use graphical approach. But when it comes to engineering systems, a number of equations that are available for us to solve might be quite huge, and we might be relying on computational systems, perhaps. So we need appropriate tools and techniques to incorporate these type of equations into the analysis and hence to our unknown parameters. So we'll take an example. I'll just take a very small example to illustrate this process. Through this process, we should be able to understand the mechanism of the Gauss elimination. And also for your exam perspective, it's probably equations of this order should be expected. So you should be able to take practice problem solving based on the approach that we are using today. So you see 3 equations on board. 8y plus 2z equals -7. 3x plus 5y plus 3z equals 8. 6x plus 2y plus 8z equals 26. These are the 3 equations Now we need to understand. We need to obtain the values of x, y, and z, which will satisfy these 3 equations. So keep this in mind. With this brief introduction, let us go into the various steps that are involved when you apply a process called Gauss elimination. As I said earlier, these are techniques that are broadly classified to solve linear equations. The main objective is algorithm.
Break the bandwidth issue and
I'll check.
Okay.
So you try to take up these equations. As I said, the main objective is to form the backbone of any computational process that you in solving equations. You try to apply them on a computation. Okay, so with that, we just look at these three equations now. I think equation number 1, I told earlier, is 8y plus 2z equals -7. 3x plus 5y plus 2z equals 8. This is equation 2. And equation 3, it is 6x plus 2y plus 8z equals 26. Now, when you're given a set of equations like this, first approach, you have got here, if you look at this equation, you've got 3 variables, x, y, and z, and 3 equations. So you have to position the equations in an appropriate order to facilitate our analysis in subsequent steps. So we have to arrange them as stated on the screen. We should have a pivot equation. Pivot equation is the primary equation position. How do you choose that? Is the first thing that you have to be very clear. All the equations, because all the terms in every equation need not be complete. That means every equation need not have all the 3 terms. You see, the first equation had only 2 terms. It didn't have x term. Whereas next 2 equations, equation 2 and equation 3, had all the 3 terms. Even though it had all the 3 terms, you look at the coefficients of x, y, and z in both the equations, they are not the same. So, you take the first coefficient x, first coefficient of x in equation 2 and 3. So you have second coefficient, you have the coefficient of x in equation 4 or higher. So based on this, you will have to reorder the equation in a way that the first equation should be the equations which have all the 3 terms, and also its first coefficient, x coefficient, becomes the highest among all the equations. That means here you have 2 equations which have all the 3 terms, equation 2 and equation 3. Out of this, equation 3, the x coefficient is the higher, so you can place the equation equation 3, the 6x plus 2y plus 8z equals 26 as the first equation. So you are rearranging the equation. Next comes 3x plus 5y, and the last equation, third one, we have placed the equation number 1, which was stated step 1 earlier, 8y plus 2z. So this is the first step that we try to do. Rearrange the equation such that you have the pivot equation.
കുറച്ച് നമുക്കൊരു ഡിസ്റ്റൻസിൽ നോക്കി നോക്കാമോ സർ? ഒന്ന് കുറച്ച് ഡിസ്റ്റൻസിൽ പിടിച്ച്.
Okay. Now, if the 3 equations which are already positioned is listed here in step 2, which then we need to write the matrix form. That we are trying to prepare the augmented matrix of this particular equations which are written there. Nothing confusing here. You look at all the coefficients of the equation, that is x, y, and z of equation 1. You move to the first row of the matrix on the right. You look at the 3x, 5y, and 2z coefficients for the second row of the matrix, and 0x plus 8y and 2z for the third row of the matrix. And you see the last column of the matrix. These are on the equations where you have the left on the right hand side terms of all the equations form here of the farther end. That's the rightmost column of the matrix. So this is the augmented form of the matrix. We are trying to have matrix operations which I am relating to what happens in the equations at each level of operations. So having formed the augmented matrix, step 3, we have to operate upon from the augmented matrix. You look at the equation 1 that's written on step 2, 6x. Now your pivot value is 6. You're trying to operate upon 6. So divide the first equation with respect to 6. So when you divide 6x by 6, get x. That's the second step 3. The first equation, step 3, the coefficient of x turns to 1 because you divide 6x by 6. First term 6. So 6x by 6, you get 1. 2y by 6, you get 0.33y. 8z by 6, you get 1.33z. 26 by 6, you get 4.33. So corresponding augmented matrix is what is written on the right also. So you are able to relate what happens in the augmented matrix and also what's happening in the equation per se. So the change that has happened, the step 3, first this equation becomes very critical. So here is the next set of operations. With the coefficient of the second row is not applied to this equation because the term was 0 here. So if you multiply, say if you apply here, instead of 3, you have taken 0 here. That means when you minus this minus 0 into this equation, no change will perhaps happen. So that's why we didn't operate upon this. So we have got two equations which are in y terms now, y terms and z terms. The first change that you have brought about is operation using the first equation as the pivot equation. Now the next exercise that we have is we need to get rid of this y, such that we'll have one equation in which you have x, y, and z. Next equation you got y and z. The last equation you have only z. When you have it only z, then it becomes more easier for you to calculate. So you repeat the next process again. New pivot equation need to be formed. So our next approach is to eliminate, as I said earlier, y term. So here you have to reorder the pivot equation. You consider these two equations. To have both equations have two terms, that is y and z, but the y term is more or higher. The coefficient of y term of the third equation is higher than the coefficient of y term in the second equation. So I'm interchanging this equation. It's currently interchanging this force. So my third equation, 8y plus 2z, is now second equation here. This becomes third equation. So if you can recall, what we did next is dividing. Yes. So we can divide that equation 8y. Let's put back here, this equation. We are dividing this equation with the coefficient of y. We divide this equation with the coefficient of y. That's 8. Get y less 0.25z equals minus 0.875. Corresponding change will happen in your matrix too. So now this is your pivot equation. You are operating upon that. You can subtract this equation, 4y minus 2z minus 4 times this equation. 4 times that equation. So what happens? The 4y minus, again, if you take the entire terms out of the bracket, you get 4y minus 4y. This entire thing becomes 0. So you get y terms gets eliminated. So you get 2z minus this term, you get minus 3z. Correspondingly, of course, you operate upon this part also that you've done here. So the equation transforms into these three equations. You get x plus 0.33y plus 1.33z, 4.332. This is the next equation. And finally, transformed equation is this. You can see it's an upper. If you look at matrix, get a matrix as a triangular matrix. Okay, get what's called as upper triangular matrix. It's very easier for you to get the solution. For the next slide. So this upper triangular matrix, minus 3z equals 1.5. So z equals minus 1.5 and minus 2.5. Back substitution of z back to y. If you substitute it back, as we said, you get y equals minus 1. Substitute z and y in x, you'll get x to 4. So your solution is Z equals 0.5, Y equals -1, X equals 4. These are the total approach steps involved in the Gauss elimination. Now you get this is the simple steps that we need to follow. You can work this out on various examples to reinforce the learning in it. With this, we'll close the Gauss elimination process and we move to the next part of the discussion, which is curve fitting. Should I stop for their doubts on this?
We can proceed further.
Yeah, so we move to the next part, which is called curve fitting. This tool becomes very handy whenever we do extensive experiments, social survey, large amount of data when we pull. If you need to understand what is the nature or what's the basic character of the data that we collected, you just need to see, you need to represent the data onto a curve or a factor which we can evolve. So this is an introductory session on how do you evolve or how you fit a curve from a given set of data. So maybe perhaps when you look.
So we have got a few questions now.
Yeah.
So I am not sure question clear. I'll read it out for you.
Yeah.
Will the answers change if we didn't divide the first equation by 6?
No, the process is it all depends upon the type of coefficient. So these are the well-tested approaches or standard approaches which is get adopted as a methodology for the Gauss elimination. There can be an error which can get embedded in the process. The moment we go on a rapid, we'll go on a different mode, which maybe per se you see the next question that has come. If you don't divide by 6, the problem is this particular process need to be applied or in the relevance of this process is in the computation domain. If you do a program for solving 100 equations, so unless you make that equation with a value of x and coefficient of x as unity, it will not be possible for you to implement that equation for the subsequent iterative process. That's the relevance of making your x coefficient unity rather than looking at the answer of the solution.
Okay. Also, one student has asked, is it important to interchange the second and third equation?
Yes, that's also very significant. Because the process is we have to arrive at the matrix operation. We are trying to operate a matrix and we are trying to form what we call as an upper triangular matrix, even though those jargons are not used, but what we try to evolve is an upper triangular matrix. Look at the graph, upper triangular matrix. So the moment if you need to arrive at the upper triangular matrix, this process are very vital. Otherwise, there can be errors that can get integrated in the subsequent, especially when it depends on the coefficient. Right? In some of the scenarios, you will run into problems.
Sir, Gauss elimination method which program could include a request to I think other method.
Oh no. That's a good problem. See, the ultimate objective of Gauss elimination is as I said, not for hand calculation. It is for you are applying this on a computation. You write a small program, but for example, say these things cannot be expected. Your university exam, you might be given equations and you'll be asked to solve them. So there, the steps of process are more wider rather than a program. But again, the understanding of a program level, now when you look into various modules which work on numerical techniques, let's say MATLAB or MATLAB when you try to use, they have built-in modules already. So when you try to approach any software, most of the softwares have built-in modules. So to write a program, of course, that is good for your own interest, maybe we can try. But for the exam perspective or maybe from the academic perspective, within this framework, perhaps I think that will be out of bounds. It's quite difficult for us to do this at this point.
Okay, sir. I think that's it.
Yeah. So now coming to the curve fitting, this is what we said earlier. We have a curve. That's what we have seen. We have seen a lot of data point, which would be the best geometrical shape to come out with this? Is it the question that you asked? Can be a straight line, or is it a parabolic curve, or is it a curve with a 30-degree, or applying still more complex curves? So, how can we get that answer? That's the thing that we have to look into this time, this discussion. Now, when we start learning the curve fitting, perhaps what comes to your mind would be previous session we had something on interpolation. There also we had data points. You're working with data points. You are trying to build up polynomials connecting the data points. Primary difference that you should have between curve fitting and interpolation is interpolation. You have given data sets on DP, and we need to understand what missing value or what could be the value. If you need to estimate a value which lies between this data point, which is the best way to do it? Should I go for a polynomial which takes, or can I go through between polynomials? These are the some of the discussions that we have in this class. This discussion is a different domain, even though we work with the data point. We are trying to understand what is the best geometrical shape that we adopt to represent the given data set. This is the difference between curve fitting and interpolation. We must be very clear in our mind before we proceed with this learning process. Okay. Now, how can we make a curve properly fit? That's the first thing that we need to have in mind. Let us say what you have seen on the screen. You have seen about 5 to 6 dots, 2 circles, which represent typical data points. This is for illustration I shown. I also have shown 3 different lines, blue, green, and red. Perhaps 3 different colors, I'd rather say, on the screen. Now, which line is the best line which will satisfy the spread of data, or which can accommodate the general character of the data? Because, so we have to rely on a theory of colors of least squares. What it says is that if you look at the point A, which we have just discussed, point A, the vertical distance of this point A, one of the red line, is a small delta. Now, another line which you have plotted, green line, you see another delta. You got a line lower, you got another delta. Likewise, every point has got a vertical deviation from its original plot to the line which you have fitted. Now, if you take up these difference that this point has with a line, difference this point has this line, difference this point has this line, this point, this point, this point. So, if you square this differences, square this vertical distance and sum it up, which line gives the least sum is the best fit line? I suppose you got it. Which line gives the least sum? That means you find out sum of the difference of the points which are actually plotted, which are got, and the line is there, which is an approximate, or we can say the best fit. So, which may not pass through this point. So, there is going to be a small deviation or difference in your y values for every x on the line and the point. So, if you square the difference and sum it up, you got n number of lines which are possible. Each line has got the least sum is the best fit line. This is what's called as a method of least square. That's what defined here. If you have got point fitted on a line, square of the distance, measure the vertical direction, and which is the least is the best. This concept should be there in your mind, because this is what helps us to evolve various equations or various solutions for the different type of curve. First, let us say, so our discussion will be limited to 2 lines, that 2 curves, one straight line and a parabolic curve. So when you have a straight line in the parabolic curve, the approach that I've adopted is I got a problem in hand, and along with the problem, I'll be trying to illustrate the equations that you need to adopt. So it becomes more easier, as well as be very clear to you on how this entire method can be adopted. The problem that I given for the discussion today is, x1. I got 5 data points. So the x having values ranging from 5, 10, 15, 20, and 25. Y have values from 16, 19, 23, 26, Okay. Now, you're given, you're asked to pick a straight line. So you're trying to see how shall we adopt the best straight line fit. Okay, give on. Everyone understands, and by this time, we know simple equation of a straight line is y equals a plus b or mx plus c, which we normally have. Now, if y equals a plus bx is the best line, or is the line that is equal to the line, then the best line, for the line to be a best fit, the objective that what we need to find is what are the values of a and b, which will help us to tell which is the best straight line which will be satisfied with this particular data. So our objective is get what is a and b and substitute it back and tell this is the equation which will fit the best for the given data. Okay, so this is what the discussion. Now, how shall we go about? I'm just trying to explain to you general equations formulations. So y equals a plus bx is the equation. Now, every data point which I stated earlier, xi, xj, yj, every data point, the graph which I've shown earlier, every data point has got an coordinate system xj, yj. From through this, I've fitted a line which is y is equal to a plus bx. So if I fitted a line y is equal to a plus bx, for every x, for every x value, this line will give a y value based on every x value, the y will find out. So for this, if you take the x value along this data point, xi, yj, that xi also will give a y value. That y value and this yj, which already existed, they are not the same, because you can see y corresponding to x is here. This has got a yi, but the straight line gives y somewhere here. So the difference which you have. So likewise, so some of these squares say this line, if I say is the best fit, then the sum of the squares of these differences of this line was least from all the possible lines I can draw using. So this is what we are trying to see. So we can say, generalizing this statement, I would rather write this as delta. Delta is the differences equal to yj, every y coordinate, minus what is the y coordinate given by this equation for every x. So this is y1 minus a plus b x1. A plus b x1 will be y corresponding to what is there on the line. So difference between this will be y minus a plus b x2. So q, so if the line to the best fit, then I should have taken the sum of squares of this entire delta. That means it should be yj minus a plus bxj, the whole square. That's what I'm going to get, whole square. And I will sum it up for all j's possible. That is all the points, let's sum it up. I call sum as q. Now this q to be, so for this line to be the best fit possible, when the sum of these squares are minimal, that means the variables are a and b, unknowns are a and b, I should have this q, I should satisfy. Q, dou q by dou a should be equal to 0, and dou q by dou b should be equal to 0. Because this is to be minimum, a has to be minimum, b has to be minimum. So it's possible only if dou q by dou a is 0, dou q by dou b. Now we have to operate this dou q by dou a, dou q by dou b on this q. Very simple operations.
Sir, screen sharing ended.
Yeah. So now there's other two equations, dou q by dou a and dou q by dou b. I'm parallelly displaying this for easiness to enable you to understand. So dou q by dou a, when I write already q I've written here. So I'm derivating. So it's with respect to a, I'm finding the derivative. So a is here. So this entire sum will be 2 into 2 into sigma, this value, yj minus a plus b xk bracket into minus a. A comes out of this bracket. So derivative of A also, that is -1. Minus A, dou by dou A, then A is a variable. Derivative of minus A is -1. So this is the next equation. First equation I will get is -2 sigma yj minus A plus bxj. This is -1 and get multiplied at -2. So perhaps -2 also can go because it's equal to 0. I can divide by -2 on both sides. So my equation will boil down, the first equation will boil down to this sigma yj minus A plus bj. Likewise, we look at this, dou b by dou b equal to 0. 2 equals the same terms. Here the difference is dou q by dou b. So if you look at this, yeah, 2 into sigma yj minus A plus bxj into, again, with respect to b, I will do the derivative. So now the coefficient of b is xj. So dou q by dou b of bj is minus xj because minus a minus b, it comes out of the bracket. So minus bj. So we get minus xj. When multiplied, you get minus 2j equal to 0. The equation. You can also again divide both sides by minus 2. So get this as xj sum. So now these equations are the equations on which we are working. Let's rearrange these equations to equivalence of operation. Sigma xj, I am taking sigma yj, I am taking this out. Take out of brackets while I have sigma a and then sigma minus bj. Here also sigma xj. Xj is outside, I multiply with this term. Sigma xj yj. I get this xj yj. Again, sigma a into xj minus sigma a xj. Again, bj.
Okay.
Now here, yeah, that's good. So you will operate, isn't it? I'll just give the prompt.
Yeah, okay.
Now, so these are the equations which we had just arrived at. If you look at yi a sigma bj equal to 0, x a yj minus axj and b xj. So the equations we have just derived. Perhaps we can little more condense these equations. Sigma yj, let it remain the same. I'm transporting both this on the other side of the equation. So if that is so, we got sigma a, that will be n, that will be n into a, that will be n, because we are adding up, a is a constant and you are adding up across all the equations. It becomes more clearer now. So you get, if there are n equations, it will be n into a. And please note this, there's a change in font to this plus or minus is plus. So this is plus when it comes here, because already it's minus. So when you get transported to this side, the Na plus B into sigma xj, you can see B into sigma. B is a constant, I'm taking this out, B into xj. Same thing happens here. These two terms are transported to the right hand side, get A into xj and B into xj squared. So these are the equations which we need to have in our mind to understand or to assess coefficients of the straight line. That's A and B estimate. These equations should be there in my mind. So the change that you put is Na plus Bxj and A plus Bxj. So let us look at, now we shift back to the problem. So we have arrived at the equation Na plus Bxj, and these equations are there. Now let us see how we can apply them on given data set. We are given x, y. These are the data which are already given. X, we got 5 sets of data. Now, what we require here to substitute in the equation is to get sigma xj. Sigma xj means the sum of all sigma yj means sum of all y terms. So sum of all y terms. You add them and you get the summation.
I think this is
Previous.
sorry.
Previous. Yeah, that's fine. So you get n. You get n is the number of data sets. You got 5 sets. Because 5, A is unknown. We need to find what A. Plus B is unknown. Sigma xj is the sum of all x. Sum of all x. You get x equals 95. So get substitute here, 25. Sigma xi, xj, yj. You got some here, xj, yj. The term answers this value are, let's say, in the next screen. X squared should be 25 plus 100 plus 25 plus 400. X squared value. Okay, you get x squared 5, x squared 10, x squared 15, 25, 20, 400. The x squared. So this one is x into y 80, 10 into 90, 190, 50 into 45. Multiplication of these two. This one 25, 30 gives that. Likewise, sum of all the x squared is equal to x squared 1375. So the sigma value of x squared, sigma value of xj picked up from here, sigma value of yj picked up from here, sigma value of xj again picked up from here, xj yj picked up from here. Let's see what's there in the next slide. Next slide, please. Next slide.
Yeah.
Yeah. So you see the next slide. You see that you see n is equal to 5. Sigma values of x squared, all these getting substituted into this. So when you get substituted into this, previous. When you get substituted into this, these are the equations that you need to solve. When you solve this equation, you get a equals 12.3, a equals 12.3, and b equals 0.7. And the equation of the straight line, what you need is y equals a plus bx, 12.3 plus 0.7. This becomes very straight line equation you need to have. This is how we adopt it. I request you to have there is an equation correction required plus some issue has happened. So Na plus bxj, Na plus bxj. That's why it is n is 5a plus b into xj is 75, and this is 75. This is 135 x squared, and xy sum is 1885. So that's what linear equation to solve, and you get this as a straight. So solve, and this is how you fit a straight line. So the straight line which fit this data is given as y is equal to 12.3. Now we look at the next case of your curve fitting. That's a parabolic. How do you fit a parabolic curve? Here also, I'm taking a problem as a demonstration. So here it can be little faster because almost process is the same. So the data set is available here. When you come to the parabolic, equation changes. Now we have an equation of a plus bx plus cx squared. See, we got a second degree form in x. So our issue is we need to get a value, we need to get what's the value for b, we need to get what's the value of c in such a way that this equation gives the best fit parabola for the equations here. Okay, in this general equation, so we start off how to get this equation. Just as we have got two equations for straight line, we need to get equations for the parabolic curve also. It's not a clear aspect. We got y, curve gives the value of y, there is no big difference. To sum up, square of the sum, to make this method of least squares, the best fit equation is the equation where you have a minimum, b minimum, and c minimum. Then only the entire equation can be. So if you take all the three equations minimum, keep this as minimum. So this is the operation that previous slide. So you have dou q by dou a, you have dou q by dou b, and of course dou q by dou c will be the next one. So when you have here dou q by dou a, this is what your equation is. You got 2 and dou q by dou a, just as we done for straight line, only the equation has gone a little larger. You got the square term divided by dou a. Look, when you give the derivative, q times into this equation, and a as it comes out of the bracket will be minus because minus 1. So minus 2, and this equation comes in this order, and minus 2 can be cancelled. So your entire equation will be of this order. If you take out this out of bracket, get sigma yj minus sigma a minus sigma bj minus sigma c xj squared equal to 0. So when you again transfer all terms to the right hand side, your equation can be written in this manner, and you can take sigma a across given data point. There are n data points. Previous n data points. We got n into a. We have b data b into xj. Another equation e into xj square. So the first equation that you get from dou q by dou a equal to 0, which we will have to combine to estimate a, b, and c. Now from dou q by dou b, same method we applied. We got q value already there. Dou q by dou b we have applied. When you apply this, we'll have 2 into basically 2 into this entire equation because it's just like x squared, it's 2x is the derivative. Likewise, this is a single function. When you do the derivative, 2 into sigma yj minus ax plus bj plus cxj squared into, of course, the b term. Now we have to go. So b derivative dou b term we have to go is minus bj. So dou q by dou b of minus bj will be minus bxj will be minus xj. Xj is a constant here, b is the variable here. So the term will be minus 2xj. So you can cancel 2 out, get this as xj multiplied by sum of yj minus a plus bxj plus cxj squared. Taking this out of the brackets, sigma into xj into yj, multiply xj and yj, xj yj, minus again sigma a into xj minus a into a minus, hello.
Sir, audio issue പറയുന്നുണ്ട് sir, ഒന്നും കൂടി ഒന്ന്.
Hello. So here xj, you multiply xj and yj, you get this as sigma xj yj minus a into xj. This is some the next term. You got xj and b xj. When you multiply, you got xj here, you got another xj here. So hence you take this out of b xj squared, and you got cxj, that's minus cxj. As it is taken out of the bracket, the value will be minus, so it will be minus cxj squared. With xj outside this, we'll give the term as xjq and c here, so it will be sigma xjq. Transport all these three terms to the right hand side. So you have xj, so it's like this previous equation, xj yj plus axj plus bxj squared plus cxjq. Same way, if I take this constant a outside, this equation can be rewritten as xj yj summing a into sum of xj's, b into sum of xj squared, c into sum of xjq. So you got two equations now. This is the equation 1, equation 2, and the next slide we'll have equation 3. Can I have the next slide? Yeah. The same. These are the same approaches. I'm moving ahead. What we did, the derivative, dou p by dou c. This derivative 2 into sigma into yj minus the entire parabolic equation into coefficient of here to have a derivative with respect to e xj squared. Xj squared is a constant. Because it do derivative with respect to c. Minus c xj squared when you do derivative to be minus xj squared. So you get minus xj squared. So once it gets minus xj squared, you got minus 2xj squared into this. Divide by 2, you get xj squared into this. Now you expand this equation. You get xj squared into yj, xj squared to minus a, axj squared, xj squared into minus bxj, that is xj, xj squared into cxj squared, you get x raised to 4. So this equation. Now you got first equation written earlier, second equation, and this is the third equation. Third equation we just try to simplify it again. Xj squared y to yj plus a into xj squared plus b into xj cubed c into xj raised to 4. You can take out the constants outside. So equation are reframed. This a is taken out, this b is taken out, c is taken out. We've got three equations that are made available for us to assess a, b, and c, because you've got three unknown constants of your parabolic equation need to be determined, for which you require three equations which are already made available. So dou Q by dou A, dou Q by dou B, and dou Q by dou C. Next slide. Yeah. So we are applying the same equation. These are the three equations which are available already, which we have come out. Now let us see for the given data set, given x, y, what all we require? We need sigma xj, sum of all xj, sigma yj, sum of all yj. We need what is xj squared we require. So we need to calculate xj squared. So 0, 0.5 squared, 1 squared, 1.5 squared, squared, and 2 points. You can sum it up. That gives sigma xj squared. What else we require? We need xj, yj. So we calculate x, y, x into y, x into y, x into y. Again, 1.5 into 2.25 is 3.75. 2 to 4, you get 8. 2.5 is 6.25. You get 15.625. So when you sum this up, you get sigma xy as 28.125. What next? You need to have again these terms x squared, you already have x cube, we require xj cube, same manner. X already is available. You compute the cube value, sum this up, you get x cube as 28.125. Now x squared y, xj squared y, already x squared exists. With y, when we multiply, we get the value of x squared y. So 0, you got this one, then x is 0.5 and y is 1.25, you get 0.0625. For these x and y terms, you get x squared y as this term. And in that manner, you're able to calculate 102.5 as x, 6.25 as y. So x squared y will be 29.065. Sum of all these values, you're able to get the sigma x squared y equals 1.115. And what remains is x raised to 4. Same way, x value is given. You can compute what's x raised to 4. Entire values of x raised to 4 against the given values of x is computed, and it's summed up, and you got the values of 61.1875. So this is how we estimate all the required values of our function. And in order to enable us to evolve this into a linear equations to be made available, we calculate A, B, and C to pick our parabola. And in meantime, n is the number of data. This equation we got 1, 4, 5, 6. So n is 6. There are 6 sets of data. That next slide, please. So now these are the data which already we have estimated. The set of equations which are already there. Now let me look at this. We are converting this into a matrix form. Matrix form means A, B, and C are the unknowns. You look at this. You multiply this matrix n into A, plus B into xj, plus C into xj squared. Y. This equation. Now if you look at the second equation, xj into A, xj squared into B, xj squared, sigma xj cube into C, into xj cube equals sigma xj yj. That's one equation 2. You look at the equation 3, xj squared yj equals A into xj squared plus B into xj cube plus C into xj raised to 4. So these equations, now we are trying to formulate into a matrix form, enable us to apply Gauss elimination, which we learned earlier, because we need to calculate, we need to estimate what are these values, A, B, and C. All the other values which you see here, we already have estimated from the previous tabulated data, and which is also displayed here. So we need to substitute these results. Results which are estimated has to be embedded into this matrix, and we have to apply the Gauss elimination, which you have just learned. Okay. Can you please? Okay. So this is the same matrix which we have used. Now we have got embedded this values here. Now we have first step which we have done is because formulation of the augmented matrix. We have got this values of the matrix and also the y values or the right hand side values are also placed now. So hence we can operate upon the matrix as we have done earlier. Yeah, next slide please. So this is the outline. Next. Now next one is what we have done is I've just written the augmented matrix again sake of discussion. Here to calculate the pivot equation. See, in this, all the three x, a, b, c are available for all the three equations. So this is the x value, the most highest value per function. So I'm interchanging this row with first. Okay, this row has to be interchanged. So when we interchange third row and the first row. So we can have in a increasing order, descending order. Maximum x axis here, then comes here, then comes here. Now pivot value. Your value is pivot value is 13.75. I'm dividing the entire first row with 13.75. So we have to convert to 1. Okay, I'm going to convert it to. Yeah, next slide. So from this, I'm just operating this. So how do you do this? You subtract the previous row, second row, minus this row multiplied by your earlier coefficient. So when you do that, you are able to eliminate this x value here, and your row becomes this value. Since we have to operate upon here also, okay, previous slide.
Previous.
So look, this is because now this one, because you have to eliminate x part or a part of these two. You have to get in a triangular matrix. So we are the next slide you can see that we have eliminated this equation, and now we are trying to eliminate this equation also. So this term also, x term also made to 0. Can we make to 0 by this terms minus 6 into this term. So that is 6 minus 6 into 1. 7.5 minus 6 into 0.045. 13.75 minus 6 into 4.7. Whereas these terms are bigger. This term is eliminated by 7.5 minus 1 into 7.5. 13.75 minus 7.5 into 2.045. 28.125 minus 7.5. Same apply to these columns. Next slide. That's how we get this. Now, next time pivoting, we are trying to. So this becomes a pivot equation. Dividing the entire term. Already this is the other term. So minus 1.5875 can be used to divide this. Get 1, and you can get this. You can get this. And also, I'm combining two steps into one. I'm eliminating this term. That means my y term. In our case, it is e term. E coefficient I'm making it 0. Now one can make, I can subtract the row 3 minus row 3 minus coefficient of row 3, that is minus 4.77 multiplied by this 4.77 minus 1 into this equation 4.77. So it becomes 0. Same, this becomes minus 12.75 minus 4.77 multiplied by minus 5. I get that. Same way I am applied here. Minus 12.95. Minus 12.95 minus 4.75 multiplied by minus 5. Apply this. This is going to. So get here also matrix is divided into triangle. This is equivalent to writing this. Now I'm just combining these equations. What does this mean? This means 2.82 into c equals this 1 b plus 3.0707 into c means this a plus, that's 1 into a plus 0.045 multiplied by b plus 4.45 multiplied by c equals 4.45. This is how you get the two equations out of this matrix operation. Now when you solve this, just take the third equation. 0.824c equals 0.84 or c equals 1. Now c is equal to 1 is back substituted. When c is 1 is back substituted, you can say b equals 3.307 minus 3.0, then b is 0. Same way, a and b is substituted, you get b is 0, c is 1, A equals 4.50 minus 4.50. Next slide. So I get A as 0, E is 0, E as 1. Our equation was y equals A plus EX plus EX squared. We got A as 0, got E as 0, E as 1x squared. Y is equal to 1x squared is your general. So you evolve a parabolic equation. It fits the best for the data, which is y equals x squared. This is how you fit a given data for a parabolic. So we have understood how a straight line can be written. The second set of data we understood parabola also how we do. With this, we can queries. Yeah.
Yes, sir. I think we have got a few questions. Is it important to make the coefficient of first term to 1? I think it's related to the first part of the discussion.
Yes, that's yes. It's that's the basic approach that is required. You have to make the pivot equation coefficient of the pivot equation the x value as 1 in the first case. When it comes to the next round of pivoting, y value has to be made 1. So it will enable you to build out an upper triangular metric. So your diagonal metric 1, 1, 1. That will enable the computation.
Yeah, and on a similar line, I think we have got another question also. Why should we choose X? Can it be Z or Y or any other way?
No, it's like this. Let us say if the equation is 2x plus 3y plus 5z equals greater than 5. I can write to this 5x. I can swap x and z, no problem. But the consistency should be there the entire process. If you have three equations x, y, and z, you should write x, y, and z in that manner. X we call if you know x, y, and z, then also in x, y, and z. Or you can write this as y, x, z, y, x, z, y, x, z. There is no hard and fast rule that x has to come first. It's a matrix operation. You have to maintain the consistency of the coefficients right to the start to the end. Is that the answer that you expected?
Yes, sir. I think that's it, sir. Yeah. So I think that's all the questions that we have got for today's session, sir. So today's topic, it was quite difficult to pull it out without using a blackboard, but the presentation was so crisp that we were able to follow all of the formulas, and even during the second part, especially when you are not changing the slides, it's quite difficult to keep up the pace also. So let me thank you on behalf of SF and also all the students who are present here for sharing such a wonderful session, sir. And I also think this topic is quite important in the exam point of view, and also it's quite hard to self-study without any guidance. Yeah, so I hope that today's session was useful to all of today's attendees. Thanks a lot, sir. Thanks a lot for joining us.